Welcome back, my dear friends. In this video we are going to learn about a delta conversion UPS. Already I have posted double conversion UPS, online line interactive UPS, offline UPS, and also rotary UPS, also hybrid UPS. So if you have not seen those videos, please go through it so that you will have a better idea about other UPS types as well. So now let us get into the topic, delta conversion online UPS. This delta conversion online UPS has delta converter and main converter, two static switches, and load, of course, source. So what is the role of a delta converter and what is the role of a main converter? We will see little later. And also how it differs from the double conversion online UPS, we will discuss now. In the double conversion online UPS, the total power required by the load is fed to the rectifier unit, and then it is fed to the inverter unit, then the converted AC is given to the load. On the other hand, if it is a battery mode, that time the power which is stored in the battery is given to the inverter, and the inverter gives the load. So that means in a normal mode of operation, in double conversion, the rectifier unit and the main inverter unit is fully loaded. The 100% load is taken from these two devices. But in the delta conversion online UPS, it is going to feed only the difference between the load requirement and the supply. If there is a difference, either if it is more or less, if it is the difference is more, then it will take the energy and store it in the battery. If the difference is less, then the battery will release the power. Say if it is 5% less, so that 5% less energy only will be given from this UPS unit. If the 5% is available more, then that 5% will be stored inside the battery. So this is how it works. So this is the difference. So now we will see how it is being achieved. So this is a simple symbolic representation of the delta conversion and double conversion online UPS system. Here the total work, you go down, carry it again back to the fifth floor, but here you go from the fourth to fifth floor. That means the only difference here, it is from the fourth floor, it is going to the ground floor, and from the ground floor to fifth floor. Here fourth to fifth, so that means only one floor is the difference. So you need to walk only one floor height. So you need not to go down fully and again to climb up. So this is a symbolic representation. Okay. So in the double conversion, as I told you, in double conversion, the total power required by the load is converted using in rectifier and the inverter unit. But in delta conversion, only the difference is given by the UPS. So now we will see the block diagram. So let me erase this all so that we can understand better. So in this block diagram, you can see there is a delta transformer. Is a delta transformer, delta inverter, main inverter, and there is a control units. For the control unit, the signal is coming from the amplifiers. So this delta converter is going to control the current, and current required to the load will be controlled from here, or current taken from the mains will be controlled from this delta converter, and also the waveform which is taken from the source will be controlled by this delta converter. magnitude, and the waveform, the type of waveform which we are taking from the mains will be controlled from this delta inverter. So that means you are going to do the current control here in the delta converter, and the main converter is going to control the voltage required to the load. So here we are going to control the voltage, and here we are going to control the current. So by controlling these two, we can control the power. Okay, so how it is achieved? Now let us see here. First we will see the current control. Say for example, I shall take the load which requires 40 kilowatts of load with 400 volt. So obviously we know the current now, 40 kilowatts divided by 400 volt. So that means 100 amperes of current is required. So this 100 amperes should be pulled from the mains. So that means the primary should carry 100 amperes of current. This delta transformer has the current ratio 5:1. So primary to secondary current ratio 5:1. So when the primary is having 100 amperes, obviously the secondary should have only 20 amperes. So these 20 amperes will be fed by this delta inverter. How we are going to get exactly 20 amperes of current in the delta inverter? Because we are going to control the pulse width modulation of the delta inverter. Okay, so this pulse width modulation is achieved, the duty cycle of this pulse width modulation is achieved by having the signal which is we are giving here. So this comparator is going to compare the actual current taken from the mains and the required current. So how we know the required current? We are going to see the DC bus link voltage. So this DC bus link voltage will give the signal how much difference is there, how much it should be maintained is given from the DC reference, and what is the exact DC bus voltage available now. So these two will give the difference signal, so or error signal. So based on this error signal, you will get the input here. So comparing these two, say for example, I need to get 5 amperes and you have here actual current also 5 amperes. So that means you gave 0 here. So the inverter will not pull anything. So if the actual current is only 4 amperes and if you have a 5 amperes requirement, so 1 ampere will be the error signal. Accordingly, the pulse width modulation will change the duty cycle so that it can pull more current. So it will also meet the load current. So this is in the current control side. And about the voltage at the load side, so this is going to be set by the IGBT power stage filter main inverters. So this is a voltage controlled pulse width modulated inverter. So here again the load voltage is given as an input. Voltage sensor will give this voltage input and the reference voltage will be given to this. The error signal will be fed to the pulse width modulation. So this, according to the error signal, the pulse width modulator will increase or decrease the duty cycle so that the voltage can be increase or decrease according to the requirement. So this is how the voltage and current is going to be controlled. So how much current it needs to take from the mains is controlled by this delta inverter. Okay, so now we will see with respect to the circuit how it is going to work. So the same example you can see here. I have the load which is of 40 kilowatts. So the voltage is set at 400 volt and the current is set at 100 amperes at the power balance point. So this is the power balance point. So the same voltage is available at this point because these two are interconnected. That is the primary coil, one side you get 400 volt here from the power balance point, and in the other side, in the first case let us assume that we have also 400 volt from the supply. So you have a 400 volt at this terminal as well. So what it means? It means there is no voltage drop across this coil, so that it acts as a lossless coil. So it acts as a lossless coil, and we are keeping it here 20 amperes current setting, so that in the primary it will take 100 amperes of current, and it will feed the current to the load. So at this stage there is no current flow going to the inverter side, and there is no current going to the battery side as well through the delta transformer as well, because the load is met by the source itself. So we are not going to do anything storing or pushing out. Now let us assume that we have 5% loss in the system. So any system will have its own losses. So let us assume the system is having 5% loss. So the load requirement is 40 kilowatts, and the loss 5%, if you calculate, you will have a 2 kilowatts. So totally 42 kilowatts power should be fed by the source. To achieve this 42 kilowatts of power drawn from the source at 400 volt. So same 400 volt we are going to maintain. So we need to have 105 amperes of current. So it is a very simple calculation. So make 42 kilowatts divided by 400. So you will get 120 or 105 amperes of current. So this is your current which is required in the primary side. So obviously you will set a 21 amperes in the secondary side. So this 21 amperes is going to be set by the delta converter, and this accordingly it will pull the 105 amperes of current in this path. Now 100 amperes of current will be fed to the load, and 5 amperes of current will be sent inside to the UPS unit, where you have a converter and a battery, and two converters and everything. So where the power is lost, so that power will be balanced. So the power loss of the switches and all those things, because of that, so the battery will be draining slowly, it will be draining. So that current will be fed to the battery, so that the battery will maintain the DC link voltage appropriately. So this is how it works. Now let us see when we have 15% voltage drop in the input side. We need 400 volt at the power balance point, but we have only 340 volt at the input side. So that means there is a voltage dip. Now how this delta transformer is going to function, how much current it is going to set, now we will see. So again 42 kilowatts is the requirement, 42 kilowatts power is the requirement, and we have only 340 volt. So if you do the calculation for this, you get 123.5 amperes in the primary side. So when we have 123.5 amperes in the primary side, you divide by 5, so you get 24.7 amperes in the secondary side of the delta transformer. So the delta transformer is set to bring 24.7 amperes of current in the secondary, so that it can pull 123.5 amperes of current from the source, so that it can manage or it can match the power requirement. It is 42 kilowatts, and the power given from the source is also 42 kilowatts. But now the problem is the voltage is decreased and the current is increased. So voltage is decreased by almost 60 volt, and the current is increased by 23.5 amperes of current. So this voltage will be maintained by this pulse width modulation by pulling the power from the battery. okay, for pulling the power from the battery, it will manage the uh, voltage here. So when it is pulling the power from the battery, so that means the battery is going to discharge. So that discharge needs to be compensated. So 23.5 amperes of current, what you are taking extra, will be fed to the battery, so that the battery will be charged as well. So that's why I told you these two converters are bidirectional converters. So here as well as here, both are bidirectional converters. Okay, so based on the pulse width modulation, so it will pull the current to the this rectifiers. We have a bypass rectifiers. So bypass rectifiers will send the current to the batteries, and the switches, when it is open, it will send the current to the power balance point, so that it will manage the voltage requirement. So this is at 15 percentage voltage drop. I will represent the same concept in a block diagram. Maybe it will be little more easier. So when the main supply can match the load requirement, so 100 percentage voltage, 100 percentage current rating, 100 percentage power, here. So the delta converter and main converter, both are not going to uh, do any work, and the power delivered or power observed will be 0 percentage both side. Now under voltage on the mains, so that means the voltage is decreased, as I told you little earlier, 50 percentage voltage is less. So this 50 percentage, 15 percentage will be fed by the delta transformer from here. So the delta transformer is going to provide that 15 percentage voltage. So it will give the voltage here, so that it will increase to 100 percentage, and the current here is 115 percentage. Now that 15 percentage extra current which is coming from the source will be fed to the battery through the main inverter, so that the main inverter is charging the battery. So one way it is taking through this way to the delta transformer, and it is going to match the power balance point. So here you need to have 400 volt, and at this point you will have 400 volt. So you need to maintain this 400 volt for our example. So here I said this as a 400 volt. So to match this 400 volt requirement, so this delta converter is going to provide the potential, and it will increase this, and the current also is increased. The extra current will be fed back here, and it will go to the battery here. So this is under voltage. And over voltage, when the voltage is more than the load requirement, here 15 volt is extra. So this 15 percentage extra time, here what happens, the 100 percentage potential, the voltage is given here, and the current is decreased to 85 percentage. So that means the 15 percentage charging takes place this way, and the current requirement will be given by this main inverter. So here it is charging, and here it is discharging. So at this point you will have 100 percentage current and 100 percentage voltage. So here the extra potential is dropped in such a way that the voltage is dropped to 100 percentage. So when it is, the voltage is dropping, the current is increasing. That extra current will be stored here, and at the same time the current is less at this point. So we need to match up that. So the main inverter will feed that 15 percentage extra current which is required. How it is achieving this? The transformer this is achieving this is based on the concept variable impedance. This is going to act as a variable impedance transformer. So when we are having this, when we are having the voltage at the source and the load same, I told you here the input side, the primary side, here both terminals is going to have 400 volt. When the same potential is applied across this coil, so now there is no loss taking place here. So when there is no loss, that means there is no impedance here. But when the voltage either increase or decrease, that time the impedance also will change here. So here you have 415 and here you have only 400. So that means 15 percentage or 15 volt is the difference. So accordingly, to match up this 15, so the impedance of the coil will change. So the impedance, that is why we call this as a variable impedance of transformer. So when the impedance is changing, so accordingly the voltage will be changed. So this property we are utilizing to match the voltage or decrease the current or whatever it is. Then if the battery need to be charged, so there is 100 percentage available voltage, so 400 volt required here, and the 400 volt available in the main source, but you need to charge the battery. In that case, you increase the current required, how much current is required to charge this battery, or how fast you need to charge the battery. So based on that, you increase the current rating. So 100 percentage current will flow here, the remaining required battery charging current will be fed through this, either 10 or 15 or 20 percentage will be fed through this main converter. So this is a normal mode of operation when the AC power is available and the load is connected to the AC source. In case if the AC power is not available, the utility is not having the supply, that time the battery will discharge fully. That means the 100 percentage load will be met by the battery through the main inverter, and it will go to the load in this way. So this is how the delta conversion UPS is going to work. So things which we need to remember is a delta inverter is a current control IGBT pulse width modulated inverter, and here the main inverter is a voltage controlled IGBT pulse width modulated inverter. Okay, so these are the two important things. Here this point I explained you, primary winding appears as a variable impedance to the power flow to our load. So at the condition where you have the two terminals at the same potential, so you have a coil, so at this terminal and at this terminal both have the same voltage, so that time you have a lossless coil here, and when the voltage difference is increased or decreased, so accordingly the impedance is changing. So that is why it is called as variable impedance. It provides a variable impedance for the power flow, so accordingly the voltage can be matched or the current flow can be matched. So bypass mode, when there is a problem in the battery or main inverter or converter, so that time we can switch on this bypass switch, so the current flow can takes place in this way to the load. So this is a bypass normal mode of operation. So this is the functionality. This is how the delta conversion UPS functions. Comparison: if you compare delta conversion UPS and double conversion UPS, the delta conversion UPS has higher efficiency with respect to load, and the input power factor is also almost near to 1. The waveforms also you can see main voltage and output voltage for both. You can see here how it looks. So we have a pure sinusoidal output waveform in the delta conversion unit. So this is a simple comparison between different type of UPS. We have standby, line interactive, double online, and delta conversion, hybrid conversion. So the power rating capacities are given, so which I explained in different videos. So it is available from zero point 0.2 to 2 kilovolt ampere. So this is a standby. Line interactive we can use from 0.5 to 5 kilovolt amperes. Double conversion 1 kilovolt ampere to 1500 kilovolt ampere, and this is most commonly used type. And also we have a delta conversion 5 to 1600 kilovolt amperes. Cost per volt ampere, the economy of this or how economic it is. So it is a low cost device. Line interactive is medium cost. So these two are high cost device. Power density, here it is very high, medium, and then service life, it is very short, medium, and it is bypass double conversion and delta conversion have long service life. Load criticality. So if you have very high critical loads, we cannot go for the standby. So we can go up to high rate of critical loads to line interactive. So very high, very complicated loads should be fed by double conversion or delta conversion units. Efficiency, as we shown in the videos, so it is high, very high, so very high. Almost both all are having good efficiencies. Power factor corrected input current. Yes, so power factor correction available in a double conversion unit and delta conversion unit also. So in two modes, either in the normal mode and bypass mode, in both modes, for double conversion, we have it on power factor corrected bypass. So in this mode, when you choose this mode, then only the power factor correction takes place. But for the delta conversion, in the normal mode itself, the this one power factor correction takes place. Okay, and because we can able to modify the input waveform as well as the magnitude. So based on that, you can control the power factor at the input so that it can match the output load in power factor. So this is the one big advantage of this delta conversion type UPS. So this is about the other parameters as well. Transfer time. So changing between the from the source to the other source, how much time it takes, 10 milliseconds. This also 10 milliseconds. For double conversion, also in bypass mode, it takes 10 millisecond, but in normal mode, it takes only 0 milliseconds. There is no time taken for changing. Power factor correction mode also, it is not taking any time. Delta conversion, again here for bypass, we have 10 millisecond time because the path for the current is going to change. It is not in line, so we need to change the current path, so it will take 10 milliseconds of time. But normal and bypass, normal and this one, it doesn't take any time. Normal mode of operation, it doesn't take any time. Okay, so that is the different classifications and different comparison for performance level comparison. Here you can see benefits and limitations for all these different type of UPSs. So we have standby, it is low cost, high efficiency, compact size. So mostly you can see this type of UPS in our home for backing up the computers. Operates on battery during brownouts, impractical over 2 kilovolt amperes. If the load is more than 2 kilovolt ampere, this is not advisable. So it is used for personal computers. Line interactive, high reliability, very high efficiency. AVR enables normal mode of operation over wide input range. So in the line interactive, we have a AVR transformer. So this AVR transformer can increase or decrease the voltage as per the voltage dip or voltage increase in the input side, so that it can match or it can provide a constant output voltage. Okay, so this is why it is having a wide range of voltage input voltage fluctuations can be matched. So it can be used up to 5 kilovolt amperes. Most popular UPS type in existence due to high reliability, ideal for rack or distributed servers. Double conversion online UPS. So this is excellent voltage conditioning because the power is going to fed by the inverter unit. So the inverter, you can have the control how much magnitude and what is the power factor required, and everything you can keep there. So what type of waveform exactly, the sine waveform, the distortions and all those things can be controlled. So excellent voltage conditioning, ease of paralleling, available high efficiency modes, expensive under 5 kilovolt amperes. So you must use this more than 5 kilo amperes. Whenever you have a 5 kilovolt amperes, more than that, then we can go for double conversion. So if you are using lesser than that, so it is not advisable. Industry standard for mission critical applications. well suited for redundant designs. Delta conversion, excellent voltage conditioning, again high efficiency. So it is impractical under 5 kilovolt amperes. You must have 5 kilovolt amperes or more than that. High efficiency reduce the lifetime cost of energy in large installations. How to size the UPS? So this is very simple. Note down the current ratings and the voltage rating of the load. So multiply this. So you get volt amperes. So how many devices are like this? Same devices. So multiply the number of devices. Say 2 device or 3 device like that. So you get a total volt amperes here. So similarly, calculate for all the loads which needs to be connected with the UPS. So you get a volt ampere, total volt ampere here. Multiply it by 1.2 times so that any further expansions or in small variations also can be tolerated with this system design. So total volt amperes into 1.2 times, you get a grand total. So this is the way you can size the UPS. So redundant deployment architectures, we have three different type of architectures: zone, serial, parallel. So these three different type of architectures are available. In zone architecture, one or more UPS provide dedicated support for a specific set of data center resource. That way, if a UPS fails during a power outage, the impact is limited to the zone that device support. Say if you have three zones, okay, the three zones, and we have power input from here and power input from this and power input from here. So in case the power failure happens at this zone, so only that UPS is going to feed these loads. So if the power failure is for short time, so of course the UPS is going to feed the load, and the alternate power source will take care, or it will come to the action once the UPS is supporting the main system. In case if the alternate powers also fails, then it will give the breathing time for all the devices to shut down properly. So if the power failure is happens here, so that means the remaining areas is protected and it will be working in a normal mode, normal way. This is zone or architecture. Now the next one is a serial cascade UPS architecture. So where the loads are connected to a common bus bar, and this common bus bar is connected to the UPS. So here there is the two UPS connected in cascaded method. So the UPS 1 and UPS 2 in normal mode. So the UPS 2 is feeding the loads through the double conversion method, rectifier and inverter. So it feeds the load. In case if this fails, the rectifier UPS 2 is failed, so that time the rectifier, the UPS 1 is going to take charge of the current power requirement, so it will send the power. So in case if both UPS fails, so that time what happens, the static switch will activated. So this static switch will bypass the current from the AC source, and it will go to this static switch and it will go to the load. So this is a cascaded UPS architecture. Then next one is a parallel UPS system. So where you have multiple UPS available, which are all connected in a different AC sources, or this one different AC sources. What happens now? The power is fed to the common bus bar. In case any one of the inverter UPS unit is not working, so the remaining two UPS can take care of the load. So all feed the output bus. So any single UPS module can be isolated for maintenance or in case of failure. Parallel system must be synchronized together to share the loads. Of course, the frequency, voltage, all those things should be same to synchronize. Okay, so we have a 3 UPS system here. In case any one of the UPS under maintenance or it is not functional, so the remaining two are the remaining, whichever the inverter whichever the UPS you want, you can choose and we can meet the load. So this is a parallel UPS system configuration. So that's it about the UPS series of video. I have explained whatever I know for the UPS systems, for a different type of UPS, and block diagram for how it works, and comparison and everything. Thank you for watching this video. If you like, share with your friends, and the more videos going to follow through.